Hello students, in this video I will be talking about the 12th lab program for the subject Data Structures Lab. The subject code is BCSL 305. Okay, let's first look at the problem statement. So the problem statement is given a file of n employee records with the set K of keys being 4-digit, which uniquely identifies and determines the record in file F. Assume that the file F is maintained in the memory by a hash table of M memory locations with L as the set of memory addresses, two digits of locations in HT, that is hash table. Let the keys in K and addresses L are integers. Develop a program in C that uses hash function, that is h of k is k mod m, that is a reminder method, and implement the hashing technique to map a given key k to the address space L. Resolve the collision, if any, using linear programming. See, when you look at the problem statement, you feel like, okay, so many things needs to be done. But the concept is actually very simple, and implementation is also, it can be done in a very simpler way. Before I go to the topic, let me explain you what is meant by hashing. What is hashing? Why is it needed? And all those things. So, first, let us look at the definition of hashing. Okay, let us look at the definition of the hashing. So, hashing is one technique. Okay, so hashing is a process of scrambling. It is a process of scrambling. It is a process of scrambling a piece of information or data, piece of information or data beyond recognition. Beyond recognition. Okay. Now, what does this even mean? Let me take you, let me help you with the example. See, when I create an email ID, sorry, um, when I create an email ID, for example, when I create an email ID, I also have a password. And when I do this save option, right? So next time I don't have to, input the password manually. I can store it in the system and then system will do the input for me, all these things. I think you already know. So where do you think the passwords are kept? Right. Passwords are usually kept in the servers. Okay. In their servers, these passwords will be kept. Now, in what form they can be kept? They can be stored as a simple text, plain text. Okay. So, if my password is txt, okay, txt123. So, txt123 could be stored as a text file in the server. Okay. Or text. What is the disadvantage of text if I store it as a text? The thing is, it can be easily, somebody, if there is a hacker and they get into the server, then everybody's passwords will be leaked because they can easily read, right? It's a plain text. That's why. Now, is there any other way of storing the password? The other one is by using the concept of encryption. What I can do is, before I store, I can encrypt this so that the hacker doesn't know, because it will become unrecognizable, right? So the hacker will not know. But what is the problem here? See, when you encrypt, you need a key. Using that only you can encrypt. Okay. Using that only you can encrypt. So when you want to decrypt, you need another decryption key also. Okay. Now, what if that encryption decryption keys itself is hacked? Then what is the point? There is a point of breach there, right? So anybody can get into your information, though the data is encrypted. The key used for encryption, if they get it, or the key, not the encryption, if they want to decrypt, if they get the key for decryption, then it is very easy, right? So that is one disadvantage in the second way of storing. So what can you do so that you can get the safety also? That means your data will be stored and nobody will be able to get or recognize what is there in that data. The password is stored in such a way that even if the hacker gets to it, they will not be able to recognize this data. So for this, we make use of hashing. Hashing completely turns your data into a data that is not recognizable. Now, how does it do that? There are several techniques. But before that, we need to know some terms. What is meant by hash function? What is meant by hash value? And what is meant by hash table? Okay, see, when you have your password, you give this to a hash function. You give this to a hash function that can be an algorithm program. So that will then be converted into hash values. It will be stored in the form of hash values. Where is it stored? It is stored in the hash table. Like this. Okay. So hash function means an algorithm that can be used in order to make your data not recognizable. So once it gets converted, the data passes through the hash function, it becomes hash value, the unrecognizable thing. And where is it stored? In the hash table. Are you clear with all these terms? What is hashing? What is hash function? What is hash value? And what is hash table? Once you're clear with this, now let us quickly look at different types of hashing. See, I will not know whatever is required for this program, that only I will discuss. Okay, so one technique of hashing is called as static hashing. Okay, in that we have something called as reminder method. Using this, you can convert your data into the hash value format and all that. So what it does is, if I want to get the hash value, for h of x, then it is that x mod m. X mod m. This is how you can do it. See, for example, I'll take this itself and show you. See, I have run the code here. Okay, see, the number of employees is 10. Okay, 10. That means in your table, see, you can input up to 10 values. Okay, so see, that is what it means. You can input up to 10 values, and 10 values, for that you have to input the keys also. Because using that keys only, the function will convert your data into unrecognizable form. Okay. Now, what about the location? See, in the hash table, how many partitions has to be done? How many partitions has to be done? See, that will be specified by the m value. Okay, so it is 15. So let's say it starts at 0, 1 up to, so last one would be 14 because it starts at 0. So you can store up to 10 values. Sorry, you can store up to 15 values in that table. And I am saying I only want to input 10 values. Now, how do I apply this reminder method on this? See, for example, I'll take the first value. So it is something like h of k is k mod m. K mod m. See here, k is 1, 2, 3, 4 mod m. 1, 2, 3, 4 mod m. So mod m is in 15. So what is 1, 2, 3, 4 mod m? Mod 15. Can you find out? 1, 2, 3, 4 mod 15. So I think it is the nearest value is 1230. So you're getting the value as 4. What does this mean? This means to say that in the fourth location, I can store this value 1, 2, 3, 4. In the table, in the fourth index, I can store the value. So can you see here? It says that only. See, 1, 2, 3, 4 means, um, it is, you can store the value in that particular location. See, next time, like this only we will do like 1, 2, 3, 5 mod 15, 1, 2, 3, 1, 2, sorry, 1, 3, 4, 6 mod 1, 4, 4, 6. Like this, you will do the reminder method. But let's assume that we have filled T of 4. This is table. In that index 4, I have filled. And let's say for some other value, I'm getting the mod value as 4 itself. After I do the modulus, I'm getting the reminder as 4 itself. Now what to do? See, 4 is already filled, right? Now if I want to fill another value, what to do? So what is the solution for this? In static hashing, using the reminder method, you will get to know where you have to store the hash value, the converted value. Now the thing is, what if there is a data already present in that location? Then what to do? So, in order to overcome the problem of this reminder method, we have a solution called as linear probing. Linear probing is a technique that will make sure that the data doesn't get overlapped. See, when there is already a data and you want to place another data in it, it is obviously going to create some collision. You don't want the collision to happen. You want the data to be neatly stored, so that every value is stored in a unique location. Now, how do you ensure that using linear probing? What it will do is, for example, if T of 4 is already filled, it will find the next location that is available. For example, let's say T of 5 is also filled with some value and T of 6 is empty. Now what it will do is it will increment the value and it will try to find out the next available location. That is a technique of linear probing. Okay, so hashing is a technique to make your data unrecognizable. In that you have hash function, you also have hash values, the converted values, and where is it stored? In the hash table. So when you are telling hash table, you should also specify the total number of values that can be stored. What is the length of your hash table also should be set. Okay. And key values also should be given. Now let us look at the program. Okay. So first we'll look at the main program. So void main, one variable called as I. You will ask the user for the number of record that needs to be stored in the hash table. And you will tell for the table how many location needs to be, it should be, it should have. So for example, I have given 15. So based on the dynamic memory allocation, it will allocate that 15, spaces. Next, initially when you create the table and 15 values are there, okay, 15 values are there. Initially, nothing will be present in all these locations, right? So when nothing is present, we tell it as -1. Okay, we call it as -1. So we go from I equal to 0. That means from the first location till the last location. Initially, everything is -1. That means your hash table is not having any values. Then you will ask the user for the key. That means what value you want to store in your hash table that you will be giving. So it can be this based on this n number. So I equal to 0, I less than n, I plus plus. Okay, so you will be able to input the values of the keys. Next, okay, see, what if you're something like, you want to, let's say your table is having a space of 4. Okay, and you already, and you once you have this is a table, okay, 4 values can be filled. And what if all the values are filled? In your function you will count, okay, how many values are filled. And if it is equal to the total space available, m, see, total number of spaces available is m. And once you once you insert, you will increment the value of count. It is a variable that will hold the number of values stored in the hash table. What if the total number of values stored in the table is equal to the space available? That means your table is full, right? So you will say that the table is full and you cannot insert any values. Otherwise, you call this function for hashing. Insert key of I. And once it is done, you will display all the values. Now, how does this insert key works? Let us see. Okay. So, I hope the main program is clear. Now, let me come to this part. So, two header files are used. Variables, one to store the key and some temporary variables. Okay. And this is for the hash table. It will return, it's a pointer. So, first location it will point. Okay. And initially we have not inserted any values. So, we are not giving any count. Count is still 0. So, we are going to give the key. For each key, it will find out the hash value. Okay. Now, see here. How does it find? Key divided by m. That will give you the index where the hash value that the key is there, right? That you have to store. So first key I have given 1, 2, 3, 4. So it would be 1, 2, 3, 4 mod the total number of locations and will give, so 4, for example. If it gives 4, then if this becomes 4, then at table's fourth index, this value will be stored like this. Are you understanding? So, and I told you, right, initially when there are no variables, values are put into the hash table, everything is -1. So, for example, if one index is full, see, one index I put some value, that is, this is 0, this is 1 and 2. Now, when I calculate for another index, what if I get it as 2 itself? I told you, if you remember, I told you, if 2 is already filled, using the concept of linear probing, it'll find the next available location. So here, see, when the index value is not equal to -1, that means in that index, if the value stored is it is not equal to -1, that means it is not empty, then what you have to do? You increase the index by 1 and try to find if that location is available. Okay. And if it is not equal to -1, then in that index you put your key. That means if 2 is full, then you try to see if 3 is available. If 3 is available, you increment the index. You are incrementing, see, index plus 1. Then you will try to put the value like this. Okay. And once you put the value, increase the count by 1 to keep track of how many values have been inserted. And how do you display the value? See, initially, if the count is 0, that means your hash table is empty. Otherwise, for each, say, total number of spaces available is m. So, for I equal to 0, I less than m, I plus plus, at for which I value you are inserting whatever element, that location also will be shown. And you will also at the end display the total count. See, I'll explain with the help of this output. See, total number of values are 10. Values that I can insert at the max is 15. So these are my 10 values. So you see, total number of values available is 15, right? So see, t of 0, t of 1 till t of 14. So when I did first value is 1, 2, 3, 4, and 1, 2, 3, 4, you'll get the modulus operator result as 4. So in 4, you will store 1, 2, 3, 4. Likewise, 1, 2, 3, 5 will be stored in t of 5. 1, 2, 1, 3, 4, 6 will be stored in like this. 1, 3, 6, 1, 3, 4, 6 is stored in 11th, like this. Okay, so all the 10 values are stored. What? Oh, see here. Where did it go? Sorry. See, all the 10 values are stored. So obviously the other 5 locations will have -1 value because that is still empty. That is what it says. And it says that the total number of records inserted is 10. I hope this concept is very clear. The lab program itself is very easy to learn. I hope you understand the video. Okay. Thank you so much. Kindly go through the video, listen to the video, and then if there is any doubts, kindly let me know. Okay. So thank you so much.